Hey everyone, it's John, and today we're going to continue back on the CCNP based Switch video series, and in this video what we're going to do is cover VTP. Now VTP is mostly a CCNA level topic, however it is covered in the CCNP Switch, so I feel this video is warranted even though I won't be getting into as much detail as usual. So what I think I'll do is do a quick recap of VTP and then mostly focus on VTP version 3 because that's really where the changes are. So with that said, let's kick on and let's do it. So as a recap, what actually is VTP and what does it do? Right, well, if you recall from your CCNA studies, if you didn't use VTP, and by the way, I should just say outright, is that it's best practice not to use VTP because the dangers of misconfiguration actually outweigh the benefits of the slight benefits of convenience you get with it. So that's just that out the way, but this is part of the curriculum, so we need to cover it. So anyway, as I was saying, without VTP, what you need to do is if you've got VLANs, common VLANs spanning, again, not good design, but let's just say we do. If we've got VLANs everywhere, without VTP, you actually have to go into each device and configure that VLAN. So for example, let's say on this switch here, we had VLAN 10, 20, 30, and 40. Same again on here. 10, 20, 30, 40. Same again here, 10, 20, 30, and 40. And of course, the same would be true of the distribution switches because you need them to actually route out towards your network up here. So, like I say, at first glance, 3 switches, each one having 4 VLANs, not a big deal, right? Okay. However, if you've got lots of VLANs or lots of access switches, if they actually span across the network, it's a lot of configuration to go into each device, log in and type VLAN 10, name, data, VLAN 20, name, voice, VLAN 30, name, servers, so on and so forth. Okay? So VTP was designed to effectively kind of cut out this just additional overhead, just allow you to make changes on a switch and have that VLAN information propagate throughout the network. Now VTP VLAN trunking protocol is actually a bit of a misnomer because it isn't a trunking protocol. What it is it's a protocol to propagate out your VLAN information. Okay, if it was named correctly, you could maybe call it a VLAN propagating protocol or something like that. Do you know what I mean? So anyway, with VTP, what we could do is we could configure a switch here as a VTP server. Actually, I should just say just to make mention of this, every switch in VTP by default is in server mode, and we'll get to that in a second, but just remember that. So if we've got a VTP domain, okay, now a domain is just a name you give to the area to pretty much denote that it's all the same VTP, VTP domain, it's well named. So what it is, if we call this VTP domain Cisco, that means that every switch within that domain will participate within the same VTP instance. So that means if switch 1, let's just tidy this up a little bit, if switch 1 is a VTP server and it adds VLAN 10, VLAN 20, VLAN 30, VLAN 40, and 50. If all of these switches are in the same VTP domain, what's going to happen is over these trunk links, VTP is going to propagate that VLAN information out. So automatically switch 5 has VLAN 10, 20, 30, 40, 50. So does switch 2, that's got all the VLAN information. So does switch 4 and switch 3. Just by virtue of having VTP configured, it's spreading that information out so you don't need to go into each device individually and type it. Okay, so at first glance this sounds pretty good, it sounds pretty efficient and pretty useful. Now the first thing which I want to do is just go over the modes just briefly. Now the first mode you can get is server mode. If you put a device into server mode, it can create VLANs, it can delete VLANs, and it can modify VLANs, okay? So that's quite a powerful setting to have, and it's a default setting, which is actually where a bit of the worry is. The next one is client. It's basically it can't delete or create VLANs, but it's going to receive VLANs, okay? So it's a supplicant to the server effectively. The last one we have is transparent mode. Transparent mode is almost a bit like being off, but it's a little bit different than being off, because what it does is if you configure a switch for VTP transparent mode, it's going to receive the VTP information and pass it on, but not apply the changes to itself. Okay, so that means that, let's say we had a switch down here, okay, connected to this switch here, and let's say we made switch 5 here transparent. Okay, now in the same instance, if switch 1, a server, adds VLAN 10, 20, 30, that will be propagated to this switch here, which will now have 10, 20, 30. This will have 10, 20, 30. This will have 10, 20, 30. This one here, which is transparent, will not apply those changes. So this one will not add 10, 20, 30, have no changes at all. However, it will pass it on to the next switch. So this switch here will still get 10, 20, 30, because it's going to be relayed through the transparent switch. The transparent switch is just not going to apply the changes to itself, but it's still fully participating in VTP in the sense that it's still going to pass on the information. Okay, so that's the basic configurations of the basic modes of VTP. Now, since we're just doing a basic review of CCNA level VTP, I think it's probably relevant to actually include VTP pruning. Now, what actually is VTP pruning? So, do you know what? I think it's probably better to draw this one out. So, let's grab a little drawing pen and keep it really simple. 3 switches daisy chained together, and they're all connected via trunk links. And they're all within the same VTP domain, so they've all got a common VLAN database. Let's say they've all got VLAN 10, 20, 30 and 40 configured on them. Now, for example, let's say down at the bottom here, this switch doesn't have any devices connected in VLAN 10, okay? So it's got it in the database, but it's not actually connected. It's not got any ports in VLAN 10. Now, if you can imagine, if we get a broadcast within VLAN 10, what's going to happen is, let's say the broadcast comes from this direction, okay? It's going to pass it down here over the trunk link, and this switch here is also going to pass it down to here over the trunk link, down to this switch here. But think about it, what really is the purpose of this switch here receiving that traffic? Because it's got no devices attached. Now, what VTP pruning does, it effectively allows the switches to communicate and say, I don't actually have any devices in this VLAN, so do not send me broadcasts for that VLAN. Okay, so what it does, it allows you, I mean, think about it, what you really could do is you could go into this link here and you could just type in switch port mode trunk, switch port trunk allowed, and just allow VLAN 20, 30, 40. Okay, you could do that, but VTP pruning allows you to do this dynamically. Okay, so you don't need, again, it's saving you time, it keeps it simple. So what it does, it doesn't allow broadcasts for that VLAN across that link unless there's actually ports within the switch of that VLAN. So now what would happen is the broadcast does come in, it gets propagated to here, but because this switch is saying don't give me VLAN 10 broadcast because I've got no ports in VLAN 10, what is going to happen is the broadcast will now stop here, which means that this link is not going to get wasted by using up unnecessary broadcast traffic. Okay, so that's just a basic recap of VTP. Now, the larger point which I want to get to is VTP revisions, or should I say the VTP revision number. Now, what actually is the VTP revision number? Well, let's say the VTP server happens to add or make a change to the database. It adds a new VLAN, it now adds VLAN 44. What's going to happen is it's also going to increment the VTP revision number by 1. Okay, for every change, the VTP revision number goes up. Now, the purpose of that is to ensure that switches know which is the latest update. Okay, so if you introduce a new server into the topology and it's got a low revision number, it's not going to overwrite all the current changes. Okay, because it's going to have maybe revision number 2, but the latest revision number is actually revision number 19. There's a lot more changes happened in then, so it gives this kind of order of precedence to the VTP process. So you would think that that sounds like quite a good security mechanism, and I suppose in a sense it is. However, there are scenarios in which this still offers no protection. So let me just discuss that. So let's just say we've got the same kind of thing. We've got a wee topology here. You've got switch 1, switch 2, switch 3. Okay, basic topology. Now, let's say the current revision number is at revision number 7. Okay, that's the latest one. And if the server here adds a new VLAN, the revision number now becomes 8. So all these switches know revision 8 is the latest one. Oh, don't do that, John. Revision number 8 is the latest one, which is all fine and well. Now let's say, just say for example, a switch happens to break in the network. Okay, this switch breaks. So what somebody does is they say, do you know what, let's quickly grab a switch, an older switch, and maybe a switch has been labbed on, so it might still actually have the same VTP domain name. The person could have the same VTP domain name and whatnot, password, it's all configured. However, they've got a lot of configurations on it, and this switch is being labbed to death. It's got a revision number of 100 or whatever it is, and you pop this new switch into the topology with the same VTP domain, but it's got a higher revision number. It's going to now supersede all of the current VTP configurations, and let's say this new server has only got VLAN 33 and 66 on it now. Suddenly all the switches in the topology all have just 66 and 33. All the current VLANs which are using all your production VLANs all get wiped straight away, and they're all changed for this higher revision configuration VLAN. So that is inherently a danger of using VTP. Now what I want to do is really discuss how that was addressed in VTP version 3, because that really is the purpose of the CCNP. It kind of drills in on VTP version 3. So I've listed some of the key points in VTP version 3. The first one being that there is no null setup. Now what is a null setup? If you don't actually explicitly configure the domain and the password, it is effectively left blank. Now in the case if you've got a new switch with a null setup and it attaches adjacently to a switch which has got a domain configured and is perhaps a dynamic desirable link, what's going to happen is your switch is going to form a trunk with that, and it's going to inherit the domain of that adjacent switch. In VTP version 3, that is no longer the case. We are going with explicit configuration. The next point is the real key point, is that only the primary server can create, modify and delete VLANs. So we're no longer going by order of precedence by highest revision number. The highest revision number wins. That's going to dictate to the rest of the network what the latest VLAN configuration should be. The only thing which dictates the VLAN configuration is the primary server. We've actually centralized that point, and in doing so we've taken away the problem of having an unknown switch with a higher revision number coming in, attaching to the network and overwriting everything with its configurations. We don't need to worry about that anymore. The next point, number 3, is that all VLAN numbers are supported, because in VTP version 1 and 2 that's limited. In the case of VTP version 3, we can support the normal range of VLANs, extended range of VLANs, it doesn't matter, it supports them all. The next thing is we've also got increased password security, and 5 private VLANs are supported. Now if you don't know what a private VLAN is, we'll get to that in maybe the next video or after that, but all we should know is that VTP version 3 supports the propagation of private VLAN information, and that's a good thing. The last thing is MST is supported, multiple spanning tree, which means that our actual multiple spanning tree information can also be propagated between switches, which really does help simplify your MST configuration. So what I want to do now is just do a quick demonstration of how to configure VTP, maybe do a bit of VTP with MST, and then wrap the video up. So let's do it. So the version I'm going to be configuring is VTP version 3, and if you remember, like I said, you actually need to configure explicitly a VTP domain in order to do so. So like I say, let's just have a wee check. Show VTP status, and we'll include VTP. You can see that right now we don't actually have a domain name configured, okay, and we're currently in VTP version 1. So if I try to change the actual version to version 3, iOS is going to say we can't do it. So VTP version 3, see that? Cannot set the version to version 3 because the domain name is not configured. So what we actually need to do is do VTP domain, just call it John, and we'll do VTP version 3, and now it's now been changed to VTP version 3. So what I'll do is I'll just ground the switches and do the same thing again. Just do VTP Dom John, VTP ver 3. Okay, so that's actually propagated, so we don't need to do that now, so we'll just do VTP version 3 in this one. These switches have actually inherited the domain name, that's why I don't need to explicitly configure it on this one. VTP ver 3. Okay. And you know what, I'll add a password as well. I'll do VTP password IPvZero. Zero. Okay, so now if we go over here and we just do our status check again, show VTP status, you're actually going to see that we're running VTP version 3, that's fine, okay? And the VTP operating mode is a server. Now if you recall, in versions 1 and 2, that should allow us to create, modify and delete VLAN. So let's try and create a VLAN, but watch what happens, okay? VLAN 10. See that? We actually can't, it's not allowed, because this device is not a primary server. So what I've got to do is I've actually got to exit global configuration mode, and from privacy exec mode, type VTP primary. So we do a basic check to make sure there's no other primary server on the domain. Once it sees that, it's now going to configure this as a primary server for the VTP domain, and we can actually start configuring our VLANs. So we're going to confirm that, and let's start testing this out. So we'll do VLAN 10, VLAN 20, VLAN 30, VLAN 40, and exit, show V. And we've created those VLANs. So let's see if we've got this propagating across to the other side. Oh, well, that should be VLAN brief. And now we see we've actually created those VLANs. And that should apply across the network. Show VLAN brief. Yep. And just try this on as well. Show VLAN brief. Yep, okay, so that's all fine. Now what I want to just quickly show you is that if you want to shut down a VLAN, there's two ways you can do it. One way propagates throughout the VTP domain, and one just happens to act locally. So if I did VLAN 20 and did shut down, you're going to see that's just going to shut down the VLAN locally. If I do a show VLAN, you're going to see that it's actually locally shut down. You see that? VLAN 20. So if I go across the network to say switch 4, you're going to see this VLAN 20 is not going to be shut down, it's still going to be active. And same again across, pick another one, this one here. Do show VLAN brief. VLAN 20 is still active. So what I can do is I can just go and do VLAN 20, no shut that. And we'll see it's now active again. So if I want to actually make the change propagate throughout the network, what I need to do is actually tell it to state suspend, suspend the state basically. So VLAN 20 and do state suspend. Just exit that and do a show VLAN brief now. And you'll see that the state is now suspended. Now this change actually will be affected across the network. So let's just grab another switch here and look at VLAN 20. Show VLAN brief. Now this one is also suspended, you see that? So suspended is different from shutdown in that suspended propagates throughout the network. Okay, so the last point I want to show you is just with configuring VTP with MST, because like I say, it can also propagate that information. But what you've got to do is you've got to actually change the modes on each switch to MST. It's not going to propagate that change, so we need to do spanning tree mode MST and conf spanning tree mode MST. Spanning tree mode MST. And the last one, MST. And now if I go across up here, now what I first want to impress upon you is that just because we're in the same VTP domain, VTP version 3 is configured, your MST configurations will not automatically be propagated, and I'll show you that. So what I'll do is just fucking type spanning tree MST configuration, and I do instance 1 has VLAN 10 and 20, and instance 2 has VLAN 30 and 40. And like I say, if you're unsure about MST, I've got a video on that. If you just go back a few videos, you'll be able to see that, because you're a bit unsure of what I'm doing here. Do revision, oh, if I can spell revision right, revision 1, and we'll just name it IPvZero. Okay. So show spanning tree MST. So I've got MST 1, which is mapped to VLANs 10 and 20, and MST 2, which is mapped to VLANs 30 and 40. But you'll notice that this is not propagated to any other switch just now. Show span MST. That's just get MST0. You see that? So the little gotcha you've got is that you need to actually do a bit of extra configuration, and I want to first point this out is that show span, or rather not spanning tree, show VTP status rather. Show VTP status. You'll notice that the VTP operating mode is transparent, so be aware of that, okay? Because when I do, when I try to create this as a primary server, if I do VTP primary, but also add on MST, you're going to see that it's going to block it. It says it can only become primary server when you're configured as a server. Now remember, the actual MST mode is in transparent, so we need to change that as well. So what we need to do is do VTP mode server MST. You see that? So now we're a server for MST, so show VTP status. And you can see we're the primary server for our VTP, and now we're also a server for VTP in our MST operation. So now we can do VTP primary MST. Give that a little second. Confirm. and that's it. So like I say, again, if you go over here and we do show VTP status, you'll see that, remember, this is still transparent. So if we do show span, it's still going to, oh, I'll just cancel that, show span MST. We're still not going to have it yet because this switch and all the other switches are still acting in transparent mode for the MST configuration. So what I'm going to do is do MST mode, VTP mode client MST. Right. Enable, I'll do VTP mode, I can type VTP, right? Mode client MST. VTP mode client MST, and the last one, VTP mode client MST. So now if we look at our switches and we do our show span, go to privileged, show span and treat MST, we're now seeing our MSTs coming up. See, we've got MST instance 2 mapped to VLAN 3040, MST instance 1 mapped to 1020. That's now been propagated. Okay. Show span MST. Same again here. MST1 is mapped to 1020. MST2 is mapped to 3040. So you've got to remember is that even though for VTP the switch might be configured as a server, for the MST its default is transparent. So in the case of the server, with MST, make it a primary, well rather make it a server first for MST, then make it the primary server, and then also change the other switches in the domain from VTP MST transparent to VTP MST clients, and then we can get that propagation of MST information. Okie doke, so that's the end of the video. I don't want to harp on too long about VTP. Like I say, it's mostly a CCNA topic, but it is touched upon the CCNP, hence I thought this video was warranted. And so that's me back in the country again, so I'll try to be a bit more frequent with the videos. And thanks very much for watching, and thanks for liking and commenting. I'm getting more of that recently, which is good. All feedback is welcome. And that's it, so thanks very much. I'll see you guys soon. Bye bye.